Hi there, welcome back to my channel, and in this video I want to take you through how to solve a linear system with multiple right hand side. So generally a linear system is represented as AS is equal to B. This is assumed to be the left hand side and this is the right hand side. So what you mean is the right hand side is more than one column. Okay, so I have a typical example for us to solve. So the problem says solve for AX equals B, where A is this and B is that. In our previous tutorials, most of the problems we've been solving, B is normally a single column of what? Entries. But now we are having a double. So how do we go by that? So this calculus family, if this is the first time being on this channel, kindly subscribe to support and also you get updated when I post useful videos like this. So let's solve this problem. So this problem here, we can solve using any of the systems, whether Gaussian elimination or you can use early decomposition any way you want to. But the only difference is that our B here is more than one column. So how do we do that? Please go by the normal approach. Let's use Gaussian elimination with partial pivoting. Gaussian elimination with partial pivoting. So whenever you are given a system, you yourself will assess the system to know the best approach. You realize that for partial pivoting, what we are trying to say is the elements that's when you take the first column, okay, the first column, always the row with the highest leading entry should always go up. Then that of the smaller entry should go down, right? So when I write my A, you see that I have 1, 2, 4, 4, 5, 6. I have 7, 8, 9. This 7 here is bigger than what? 4 is bigger than 1. So what I do is I will send this 7 up and exchange this 7 here with the 1 here, right? For that reason, I'll switch rows. So what I'm going to do is I'll introduce my what? X1, X2, X3, okay? And this should be equal to the B. The B is 2, but let's take them as if it's independent, 2, 4, 6, right? So see how I'm going to solve this problem. So with this, my first row operation is what? My row 3 is moving into what? Row 1. So my row operation gives me 7, 8, 9, 4, 5, 6, 1, 2, 4. Then I have x1, x2, x3. This is giving me what? 5 and 6 will move up, right? 5, 6, right? So I have 3, 1. Then I have 4, 2 here, like it. So it's the same as the usual, right? So you move on. So once now my leading entry for the first row is bigger than the others, then I can go ahead and find my multiplier, right? So here my multiplier is simply equal to, so let me use the two row operations. For the first row, this is the pivot row, row 1. The multiplier is simply to eliminate the 4. The multiplier will be what? 4 over 7 multiplying row 1. Then the row operation will be what? Row 2 minus 4 over 7 row 1, all going into row 2. Then the second, to eliminate 1, the same thing happens. So you have 1 over 7 R1 as the multiplier. Then you have R3 minus 1 over 7 R1 going into R3. So with these two operations, I should be able to get my calculation right here. So when I rewrite this, my first row is maintained, 7, 8, 9 is maintained. Then for the second row, I'll have 4. You see, it's R2 minus 4 on 7 R1, right? So R2, I have 4 minus 4 on 7 times my R1, which is 7, and that is 0. So here becomes 0. When I come to this side, I'll have 1 for the one side. So here let me do for the second row. When I'm done, I'll come to this. So I go to 5. 5 minus what? 4 on 7, multiplying what? 8, right? So multiplying 8 here. So multiplying 8, and I'm getting 3 on 7 here. 3 on 7. Then 6 minus 4 on 7, multiplying 9. Okay, multiplying this 9. Then that is 6 on 7. Then final row, I'm having 1. So I'm going to use this row operation. So 1 minus 1 on 7 times my R1, which is what? 7, right? So times 7. And that will also give me 0 for this side. Then 2, I'll have 2 minus 1 on 7 multiplying what? 8, right? So multiplying 8, and that is 6 on 7. Then this one too is 4 minus 1 on 7. So 4 minus 1 on 7 multiplying what? 9. And that is 19 on 7. So this is it. So my x1, my x2, x3. Please take note, when we are swapping rows, our x1 and x2 won't be affected, but your b is affected. So we come to the b. Here is 5, here is 6. So for this side, I'm going to have 3 minus, so I'm using the first equation, 4 on 7 multiplying out the r1, which is 5, right? The r1 here is 5. When you come here is 5. So times 5, and I'm getting 1 on 7 here. So this is 1 on 7. Then the last one is 1. So we can do for root 2. So here is what? 4 minus 1 on 7. 4 minus 1 on 7. Multiplying my r1, where my r1 is what? 6, right? And that is equal to, sorry, I'm using 4 minus 4 on 7 instead, times my r1, which is what? 6. And that is giving me 4 on 7 this side. And when you come to the last row, we are using this equation, r3 minus 1 on 7. So I'll have 1 minus 1 on 7 multiplying what? 5, right? So this 2 on 7. Then this side too, I get 2 minus 1 on 7 multiplying my what? 6. So that's 8 on 7. So we still go again. So when I reach here, we're using partial pivoting. Ask yourself, this and this, which one is bigger? You can see 6 on 7 is bigger than 3 on 7. So you need to do another swapping. Here is root 2. Here is root 3. So when I do swapping, I'm going to simply get 7. So I write root 2, root 3. So 7, 8, 9, 0, 6 on 7, 19 on 7, 0, 3 on 7, 6 on 7, x1, x2, x3, right? This is equal to 5, 2 on 7, 1 on 7, then 6, 8 on 7, 4 on 7. I've also swapped this side too, like this. The next thing is to find our last multiplier. So is this on this, okay? So 3 on 7 divided by 6 on 7, multiplying this root 2 here. Now our new pivot, we have to tackle the 2 by 2. So multiplying root 2, then what do we get for this? We are going to get 3 on 6, right? Because you get 3 on 7 times what? 7 on 6. So it will cancel. So 1 on 2. I'm getting 1 on 2 R2 as my multiplier. So therefore, I'll subtract x from my what? Root 3. So root 3 minus 1 on 2 root 2, all going into root 3 will be our last row operation. So writing my matrix back, 7, 8, 9, right? 0, 6 on 7, 19 on 7, 0. Then now I'm going to get this one to be 0, obviously. Then I'll have 6 on 7. 6 on 7. So it's half. So minus 0.5 times what? Root 2. And that is what? 19 on 7. Right? So I'm getting negative half. So this place becomes negative half. Okay. Multiplying x1, x2, x3. Okay. Is equal to, I'll do same for this side. So 5 and 6. So for this side, I'm going to get 1 on 7 minus 0.5 times what? The R2. And the R2 is what? 2 on 7. And that gives me 0. So I'll have 2 on 7 here, then I'll have 0 here. Then when I come to this side, here is 8 on 7. Then I'll have 4 on 7, right? Minus 0.5 times the 8 on 7 I have here. And that is also 0. So now I'm done reducing my matrix into the upper triangular matrix. So now I can find two sets of x values, right? So two sets. So here I'll decompose and I'll get this 7, 8, 9, 0, 6 on 7, 19 on 7, 0, 0, negative half. Then I'll have x1, x2, x3 like this is equal to 5, 2 out of 7, 0, right, as one of them. Then I will have 7, 8, 9, 0, 6 out of 7, 19 on 7, 0, 0, negative half. Multiplying what? X1, x2, x3 is equal to 6, 8 on 7, 0. So these two sets will give me two different values of what? X, right? So for this side, I'll have negative 1 out of 2 x3 is equal to 0. So x3 is equal to 0. So I'll have 6 on 7 x2 plus 19 on 7 x3 is equal to 2 on 7, right? X3 is 0, so this will go. So 6 on 7 x2 is equal to 2 on 7. When I multiply, I'm getting x2 to be equal to 1 on not 3, right? 1 on 3. Then finally, I'll have 7x1 plus 8x2 plus 9x3 equals 5, right? So x1, I don't know, plus 8x2. My x2 is what? It's giving us 1 on 3. So 8 multiplying 1 on 3 plus 9. My x3 is 0 equals 5. So obviously 7x1 plus 8 on 3 is equal to 5, right? So 5 minus 8 on 3, which is giving me 7 on 3. So I'm going to get x1 is equal to 7 on 3 times 1 on 7. Okay, so to cancel, so I'll get 1 on 3. So here I'm going to get x1, x2, x3 as x1 is what? 1 on 3. X2 is giving us 1 on 3. Then I'll have 0. Now let me come to this side. So this side, so obviously I'll have negative half x3 equals 0. So x3 is equal to 0. Then I also have 6 on 7 x1, x2 plus 19 on 7 x3 is equal to 8 on 7, right? So x3 is 0. So obviously 6 on 7 x2 is equal to 8 on 7. So when I cancel, you get x2 to be equal to 8 on 6, which is the same as 4 on 3. Then I'll have 7x1 plus 8x2 plus 9x3 equals 6. 7x1, I know x3 is 0, so plus 8, my x2 is 4 on 3 equals 6, right? So I'll have 6 minus, so I'm going to have 32 on 3. That is giving me negative 14 on 3. So 7x1 is equal to negative 14 on 3, right? So I can just simply say x1 is equal to negative 2 on not 3. So here I'll write x1, x2, x3 is equal to my x1 negative 2 on 3, x2 4 on 3, and x3 0. So this is the end of this video, and this is how we solve a multiple right hand side whenever you make this. Thank you for being with me in this video. Kindly subscribe to support, and also don't forget to like and share.